Today we're going to crank through 5C.3, that's all we'll touch on up here. An opportunity to ask questions about all of 5C and looking to finish up the chapter on Friday with 5D. So we start off with a solar sail. So if you're doing physics, one of your applications would be solar sails, I think it was historically anyway. And so there's sort of this new technology we're developing that has constant acceleration, always accelerating. And so this is the acceleration function for a solar sail. We're asked to find the velocity function given the initial velocity is 0. So we've seen from calculus that if you derive the displacement function, if you differentiate it, you get the velocity function. If you differentiate the velocity function, you get the acceleration function. So therefore, if we integrate the acceleration function, we're going to get the velocity function. We need to find the velocity function, so that's what we're going to do. We're going to integrate 100 on t plus 2 squared. Now we don't have a boundary, it's an indefinite integral, which means we will need our plus c. And we're integrating with regards to t, that's our variable here, isn't it? We've got the acceleration with regards to time. So first we're going to rearrange this. We can even bring the 100 out the front, I suppose. But we've got t plus 2 to the power of 2. That's what we're performing the integral of. You could expand that, okay? You could expand that quadratic and integrate accordingly, or we can integrate using the integral of ax plus b to the power of n. Okay? So we might just do this one. It's going to be 100 times 1 on 1 of t plus 2 to the power of 2 plus 1 on top of 2 plus 1. Okay, so that's 1 on a, ax plus b to the power of n plus 1 on top of n plus 1. That's our formula for integrating ax plus b to the power of n. All right, let's simplify that. What have we got? We're going to have 100 times t plus 2 to the power of 3 on top of 3, and don't forget our plus c.
When you pull 100 out the front, is the to the power of 2, is that still to the power of 2, or is that a negative?
Minus 2. On that second.
As it was on.
Oh yeah, you're absolutely correct. That should be negative. Yep, so we've got minus 2 plus 1, so we've got 1. Yeah, great pickup. And at the bottom you will have minus 1 as well. Minus 2 plus 1. Thank you.
Is it minus 2 plus 1?
Positive 1. Negative 1. Yep. Yep. Yes. Okay. All right. So then what does that look like? That's 100 on t plus 2 plus c, isn't it? That's our v of t function. Okay, 100 on t plus 2 plus c. And then we have v of 0. When time is 0, the velocity is 0. Okay? V of 0 is 0. So that means when we put 0 into this equation, we'll have 100 on 2 plus c is 0. So 50 plus c is 0. So c is minus 50.
That bottom 100 on t plus 2, yeah, is that negative? Because the negative on the bottom? Negative 1?
Would it go to 1?
Negative here, isn't it? we've made a mess of this. Negative, the whole thing is negative.
Yeah.
Just restart
So, yeah,
this
we'll
video.
just
And that's positive 50.
So then we have positive. So then we have positive 50. Yeah. There we go. All right. Any more? One of those days. Okay. So then in part B, find the integral from 0 to 300 of v of t. So we're finding the integral from 0 to 300 of this function. And state its significance. So I'm going to use my calculator here because I don't think we've looked at integrating ax plus b to the power of n when n is -1, because it becomes some function of a natural logarithm. So that's beyond the scope of the course. So for that calculation, we are just going to use our calculator. So let's go to run that. I'm not even going to graph it. I'm just going to go into run that. I'm calculating the integral from 0 to 300 of minus 100 on x plus 2 plus 50. And I've got 14,498.27. Okay, so three significant figures. You look at the first four numbers and round the fourth one. So we're going to have 14,500. And what is the significance of it? Okay, this is going to be how far the sail has travelled. This is its displacement. Because the integral, the definite integral of the velocity function is displacement. Displacement of solar sail after 300 seconds is 14.5 kilometres. Okay, so what did we have to do there? Part A, integrate the acceleration function, because we know when we integrate acceleration, that's going to give us velocity. Then we had this plus c, so we had to solve for plus c by inputting when time is 0, the velocity is 0, so we've done that. Here's the full velocity function, and then we're applying it. We're saying, what's the integral from 0 to 300? What's the significance of it? Well, if we calculate that, this is the number we've got, and we know the integral of the velocity function will always be displacement, and occasionally it'll be distance, depending on if it's got positive and negative velocities over the time in which you're integrating it. But it will always be displacement from the point of origin. So that's a safe way to answer the question. Okay, so 5C.3, you see they really flow on from one another, they really flow on from what we've done in applications in calculus. Let's give it a go.